Okay, so last short video from a introduction point of view, just going to mention two different types of equilibria that we come across. Let's have a look now. So first of all, we have what's known as a homogeneous equilibrium. A homogeneous equilibrium, as it says homogeneous, it's all same, and so what we're looking at is everything present is in the same phase. So all reactants, all products are same phase. So the example I'm showing here is where all the constituents of the equilibrium are in the gas phase. And so that's pretty common. You have reacting gases in the same reaction chamber and they reach an equilibrium, but they all remain as gases. Second type of equilibrium is what's known as a heterogeneous equilibrium. So heterogeneous as in different. And so here we have things present, constituents of the equilibrium present in more than one phase. So what you see here commonly is a solid gas equilibrium, and that's what's shown here. The thermal decomposition of calcium carbonate yields calcium oxide and CO2 gas, and that ends up forming an equilibrium. And so what you have is CO2 colliding with calcium oxide to produce calcium carbonate, but these are both solid, and yet the CO2 is in the gas phase. And so that's a common type of heterogeneous equilibrium. The other thing I did want to mention was something about an equilibrium. This is a homogeneous equilibrium. This is homogeneous as in all gases. But what we can do here is see the other way to express an equilibrium constant. And so, for example, if this is N2 plus O2 yielding nitrogen dioxide, or nitrogen monoxide, sorry, so that balances that equation. And so what you have is all gas particles. And what do you know about this system in terms of pressure? Well, you know the total pressure. And the total pressure, as we learned last year, comes from the sum of the partial pressures of all the gases. So that's going to be this. And so if you know these partial pressures, so if these are known, you can write an equilibrium expression, and that is going to be Kp. And remember I mentioned equilibrium constant with this lowercase p means this is in terms of partial pressures of the gases in the system at equilibrium. And so the equilibrium expression for this is no different, except it's not in terms of concentration, it's in terms of pressure. So this is going to be Pno squared divided by Pn2 times partial pressure of oxygen. And so that's an equilibrium expression for a homogeneous equilibrium, but that's the equilibrium expression in terms of pressure. Now, writing an equilibrium expression for a heterogeneous equilibrium is a little different. So there's another example. Carbon solid plus water vapor yields hydrogen gas and carbon monoxide. And so this expression recognizes the fact that solids don't actually change in terms of concentration. So the concentration of carbon solid at equilibrium is going to be the same basically as the concentration of carbon at any other time. Concentration of solids, that is an amount per unit volume, don't change. And so this is incorporated basically into the equilibrium constant, so the equilibrium expression becomes a little simpler. So for this particular heterogeneous equilibrium, we ignore anything in the solid or liquid phase. All we have is solids, but we ignore anything in the solid phase then. And so what we have is concentration of carbon monoxide gas divided by the concentration of water vapor. No solids in expression. Okay, and again, because the concentration of solids because the concentration of solids doesn't actually change. Same would apply for liquids in a heterogeneous equilibrium. The concentration of the liquids does not change. So here's another common expression. You're going to see this, and this actually ends up simplifying quite a lot. So equilibrium expression is going to be copper ion, copper 2, divided by silver ion squared. Again, we leave out the solids in this heterogeneous equilibrium because their concentrations are constant. And that's it for types of equilibria. So that concludes this video.